Hello. So we are going to look at these parametric equations, and based on the graph that they make, we're going to determine the equation of the tangent line to the graph at t equals -2. So this is one. In a previous video, we looked at a lot of stuff with these parametric equations. Um, we didn't look at tangent line. Just as a reminder, or if you hadn't seen it, this is how what this curve looks like based off these parametric equations. As t is increasing, it's plotting the graph, and it looks like that. So we're going to look at the equation of the tangent line at the specific point where t equals 2. So we'll get back to that graph after we figure this out. So your regular function tangent line, which we're going to use, even though this is not a function of x, is y minus f of -2, or just the y value, equals the derivative at -2 times x plus 2. Now, these are t values I plugged in here, so it's not really a valid tangent line equation based off it being functions, but here's what we're looking for. We're looking for the y value when t equals -2. We're looking for the x value when t equals -2. So I'm not done with this part yet. And we're looking for the slope when t equals -2. So this is just how you can look at it based off the normal tangent lines we usually do. So x value, y value, slope. And then we just calculate those. So x and y are easy because they're given. So when t equals -2, according to this equation, x would be 4 plus 4, which is 8. So -2 squared is 4, minus 2 times the -2, okay. And then the y value would be -2 cubed, which is -8, plus 6, or -2. So we've gotten this and this. The derivative, which we calculated in a previous video, but it's easy, we'll do it again. The derivative of y with respect to x is the derivative of y with respect to t over the derivative of with respect to t, which is just 3t squared minus 3 over 2t minus 2. So I just took the derivative of each separate parametric equation. And now we have to determine what that derivative is when t equals -2, and we're there. So when you plug -2 into this derivative, you will get 3 times 4 is 12 minus 3 is 9. And 2 times a -2 is -4 minus 2 is a -6. Or just -3 halves. So our final equation of the tangent line is y minus y1 equals the slope times x minus x1. That's it. That's the equation of the tangent line. I'm going to convert that to like y equals mx plus b, and we're going to look at it. So 8 divided by 2 is 4. 4 times 3 is 12. We have y equals -3 halves x plus 10. So looking at the graph, we're going to check this quickly. Here is the graph. I'm moving t up. If you can see, b is my value of t. So it's increasing. I'm going to try to stop. Well, t equals -2 is right here. So if you look at that coordinate, that's 8 comma -2. So that's a pretty good check of my x and y values right there, 8 comma -2. So that looks good. Um, I'm going to finish the graph. Just keep in mind that point, that green point there is where we're finding the tangent line. So now I'm going to type in the tangent line. I'll just do it over this. We got y equals -3/2x. And I forget, I think it was -3/2x plus 10. So I'll add my plus 10 to that tangent line. And then it should look like a tangent line at that point. And it is. So that's a really good check, a visual check, and that's it. Pretty cool.